It is really wonderful to be back here, and it's wonderful to see all of the familiar faces and names from past institutes. Can you think of a problem? Let's see, this isn't a big problem. This is a series of maybe of small problems. Problems that are so small, they kind of go under the radar. Maybe it's a problem between just a few people. Maybe it's a societal problem. Maybe it's a problem with something physical. Something that's small enough and sort of irritating enough that you don't like it, but it's too small to do something about, and sometimes you need a structural fix to fix it. We know lots of classes of those types of problems. The thing about those types of problems is the chickens always come home to roost. And so the seminar that I would like to lead this summer is about one of those problems. And the problem is infectious respiratory disease. And the event in which the chickens came home to roost was COVID-19. So I'm talking about respiratory diseases like cold, flu, I guess COVID now. The types of things that make your students sneeze and cough incessantly throughout the winter months. Infectious respiratory disease is a large cause of illness and death throughout the world. Your chance, or your children's chance of getting an infectious respiratory disease next year is 100%. Okay, 99%. There's some people who somehow avoid it, but statistically it's 100% because on average we get 3 to 5 of these a year. To compare that with something like getting sick from drinking water. When's the last time that you got a stomach illness from drinking water? Turns out your chance is about 1 in 10,000 in America for having that happen to you within any particular year. But we have tolerated respiratory diseases because respiratory diseases don't necessarily put us in hospitals unless they're severe or we're severely immunocompromised. And the fix for something like that is pretty difficult. How do you interrupt something that is largely transmitted by air or transmitted by close contact between people without changing society? So the seminar, and then I'll say one more thing about respiratory diseases. They're exacerbated by the fact that we don't really have therapeutics for it, and we don't have ways of hardening our buildings in our schools and changing our society to really reduce these risks. So this is what the seminar is about, and we can look at it in all kinds of different angles. And I think we all now have enough experience with respiratory disease, and certainly with something like COVID-19, that we can think about the myriad ways that this impacts our society. So let's think about physics. If I drop a bowling ball, it's going to fall at a pretty normal pace. If I drop a tennis ball, it's going to fall about the same speed. What if I drop a bacterium? Or what if I drop a virus? Turns out you can't see it fall because it's too small, but it also doesn't fall, right? It stays suspended in the air. And the reason for that is just the physics of it. It's the surface area to volume ratio and something called the drag coefficient that becomes important when things are small. The physics of the way that a virus sees the world is very different than the physics that you and I are exposed to every day and have an intuition to. So we'll learn a little bit about that. We can learn about the biology. What's messenger RNA? Why was that just an obvious way to make a vaccine? And what's the scary thing about making mRNA vaccines? We can think about the biology of it. And I know that there have been past seminars on evolutionary biology. Why did COVID evolve so fast? Why doesn't measles evolve the same way that COVID evolves? Why doesn't rhinovirus evolve? Why are there just one prevalent strain of COVID and there's 54 or 208 or some large number of strains of rhinovirus that causes the common cold? What about the epidemiology? My favorite word is the word virome. It's a list of all the viruses that you might find in a particular sample, say an air sample or a dust sample, or a sample from a desk in your student's room. We've done some research on this. What do you think the chances are if you have a junior high school student and they're going to sit at 5 different desks within a day, and it's, sometime between October and March of the year, what do you think the chances are that they're going to sit at a desk where we can detect an infectious respiratory virus? It turns out we've measured this. It's like 90% with error bars, so it could be 100%. That's right. So that's a scientific way of thinking about it, of course, but this impacts all of us. This impacts society. And so there's historical ways to think about this. There's the technological ways to think about this. One of my favorite things to do is to kill infectious viruses. And there's lots of ways to think about doing that and thinking about whether technology can get us out of this problem we have or not. But we also can think about how society has historically acted with respiratory viruses and our problems and how we currently act with it. I mean, what is the deal with wearing a mask? Should we wear a mask? Should we not wear a mask? What's the deal with people rejecting science during a time of need? What's the whole thing with virtue signaling? Did that ever help anybody? Does this hygiene theater, this idea that we have to wipe off everything and be as careful as we can, even though we know that that may not be the most important thing? And has that helped us through these types of situations at all? So we can address many, many other aspects of how society solves its problems and how we respond to crises, or how we respond to these low-lying questions that take a big effort to fix. The seminar, because of that kind of diversity, I think, of things that we'd like to introduce into it, is appropriate for many, many different grade levels. It's also appropriate for many different teachers and areas of education, science, technology, history, you name it. Some of the most important things about human health and infectious disease have been written about in literature. And some of the best insights that you'll ever have about this is by going back and looking at history. It doesn't have to be technology driven. It doesn't have to be science driven, but there's also a lot of fertile ground in technology and science to talk about that. So with that, I'm happy to answer any questions I think afterward, and I'll leave things up to the next speaker. And again, it's lovely to see you all again.